Ohm's law is probably one of the most important things you need to remember in this course because it gives you the most important equation for electricity. Now, Ohm's law, discovered by Ohm, who we named the unit of resistance after, is that the current through a conductor is proportional to the potential difference across it, provided the temperature is constant. Now, this might sound really confusing right now, but we just need to break it down. So, it's telling us that current and potential difference are related. Now, this word proportional here, I'm sure you've come across it in maths, but that just means that we can write a sum about it, okay? So if it's proportional, we can write an equals kind of sum. And that sum is really, really important. Resistance is equal to voltage divided by current, okay? So Ohm's law tells us this. This is all it's kind of saying, is that resistance equals voltage divided by current, but that's that in words. We can write that to make it easier as R equals V over I. So it's much quicker to write in that way. Now there's one more thing that we need to look at here, okay? It says one more thing to be careful about. Provided that the temperature is constant. And that's a really important thing to add into your definition. If they ever ask you what it is in the exam, make sure you've got provided the temperature is constant. And that's because of what we were talking about in the last section. So if I bring that sheet back really quickly, we said that resistors heat up as a current flows through them because of the collisions between electrons and the ions. Okay, and that causes energy to be transferred, which causes the heat or the temperature to increase. Now, if you've increased the temperature of a resistor, you've made the atoms or the ions in that resistor start to jiggle about more. So these ions, as we increase the temperature, move about more and more and more. So you can imagine now, if I've got all these ions jiggling around in a big mess, and I've got electrons trying to get through them, as we increase the temperature, it's going to be harder and harder for those electrons to get through because it's more likely, if you can think about trying to run through a rugby team who are stood nice and still, you can see the gaps. But if they're running around crazy and jumping around, it's going to be much harder to get through because you're going to be more likely to collide with them. So the resistance is going to change. So we need to keep the temperature constant for that to work. So it's all about, if we increase the temperature, we increase the resistance. And we need to kind of remember that in our definition. So we put that extra sentence in there to help us remember that. So Ohm's law is pretty easily proved with a practical, and you've probably done this one in class. So this is the equipment that you will have used. This dot, these two dots up here, this means a power source, so probably not a battery for this one. You probably used a power pack. So this is a power source. And we can see that we have a nice simple circuit with just a resistor, an ammeter to measure the current in the circuit, and a voltmeter to measure the potential difference across the resistor. What we do is we can set all this up like it is, and then we start to increase the voltage slowly and see what happens to the current. So maybe we might have the following data. So we might increase the voltage by 1 volt each time. 1, 2, 3, 4, 5. And that's why we usually use a variable power supply because it's easier to change the voltage than the current. And you should see that the current will increase as we go along. So if we increase the voltage, maybe we started with 0.1 amps of current, it would start to go up. And often you see this kind of nice relationship depending on what batteries you use, but it would go up something like this. Now, this is obviously kind of perfect world results. In real life and definitely in physics, things like to go wrong a lot, and you won't get as good a pattern. But in general, you'll get something where the voltage is increasing and so is the current. What you then do is you plot this on a current voltage graph. Okay, so I plot each point. So if I look and I make my marks up here, so this would be 0.1, 0.2, 0.3, I'm sure you get the point, 0.5, and these ones here, 1, 2, 3, 4, 5. But then plot my points, little crosses. We always use little crosses in science, and we always try and use a scatter graph if we can in physics, definitely. You might use bar graphs more in biology, but in physics we generally use a scatter graph. And then we draw a line of best fit. So we can see there's a nice straight line relation. And this straight line is there because it's proportional. So because you've got a straight line, we've proved that current and voltage are proportional, which is, if we think about it, is exactly what Ohm's law said before. The current through a conductor is proportional to potential difference, provided the temperature is constant. And here, we've not increased the temperature, so we're okay. So, if I then replace this resistor with a higher resistance resistor, this here, if I made it a bigger one, so maybe this was a 10 ohm resistor, and now I've made it into a 20 ohm resistor, and did the experiment all over again, and I drew a graph, I'd see something that looks like this, which is kind of odd because you'd expect a higher resistor, you'd expect it to have a higher gradient or a steeper line, but no. So I'm going to draw this, remember this here, so this is higher resistance. Now, if you really want to go into the maths of this, this is because, ignore if you don't like maths, R equals V over I, but when we look at the gradient, we're at grad, that's usually equal to, well, it's always equal to y divided by x, isn't it? How far up divided by how far across. Now, if we look at that in terms of I and V, that's actually equal to I divided by V, which is the opposite of resistance. So R equals V over I, but gradient equals I over V. The really important thing to know, ignore that if it's too confusing, is that the steeper the graph, the lower the resistance. So if you're ever asked to describe a experiment that will help you prove Ohm's law and how you would do it, this is what you need to think about. We have our circuit with a resistor, a voltmeter, an ammeter, and a variable power source. We find data for increasing voltage and we see what happens to the current. We plot them on a graph and then we look at this, the line, and we see it's a straight line. So we've proved that Ohm's law is true because a straight line means that the two things that you're plotting, I and V, are proportional to each other. Now, we talked about this equation here for our other part of Ohm's law. So there's two kind of thoughts about Ohm's law. One, a straight line graph. Two, it gives us this really useful equation. R equals V over I. Resistance equals voltage divided by current. I'm going to write that again here. Resistance equals voltage divided by current. And as you do more and more physics, it becomes so much easier to just write everything in symbol because there just becomes so many equations, you don't have to write them out all the time. And we can use this in the sum kind of questions that you get asked. So this question here is a nice example. What's the resistance of a bulb which has a potential difference of 12 volts across it and a current of 2 amps running through it? So the really important things to notice here is that they're asking us about the resistance. We know what the potential difference is and we know what the current is. And what I like to do to make sure I've got everything in my head, I'll write these out so it's smaller. So I'll put R equals, I'm not sure yet, V equals 12 volts, and I, which is remember current, is equal to 2 amps. Now, here I can just use the equation straight off. Resistance equals voltage over current. I don't need to rearrange it in any way. So R is equal to V divided by I, which is equal to 12 volts divided by 2 amps. And remember, with dividing by, it's really important that you get these two the right way around. It's not like multiplying, you can't put them any way. You have to make sure the voltage is on top. And that, 12 divided by 2, is simply equal to 6. And what's really important now is that I have my units. So units are vital. Sometimes in the exam, you will get given the units, but often you'll get a mark for knowing those units. So if you get the answer wrong, if you put the units down, you might get a mark. Also in the exam, it's really important to write this kind of thing down. For a 3-mark question, like if this was a 3-mark question, you'd get 1 mark for writing this down, 1 mark for writing this down, and 1 mark for writing this down. So even if you got this sum wrong, but you'd written these two things right, you could still get 2 marks. But if you got the sum wrong and didn't write these, you wouldn't get any marks at all. So it's always worth writing out your working. Now, there's 2 more ways they can ask this question. So here we've got a separate one. What is the voltage across a 5 ohm resistor carrying a current of 4 amps? So we look at this one again. R is equal to 5 ohms. V is equal to we don't know. I is equal to 4 amps. Now we said before that R is equal to V over I. And we can see now that it's not arranged in the right way for us to use. We haven't got V on its own. So you need to think how we're going to do that. Now there's 2 ways for us to think about how that works. Either you think to yourself, I'm going to rearrange this as I would a normal equation in maths. And all I do then, if I want to rearrange this, is I look at what I want on my own. I want V on its own. Then I've got I here. I need to get I onto the other side. V is being divided by I here. So all I need to do is move I up there. So V is equal to IR, which is how often you might see Ohm's law written as, actually. V equals IR. If you don't like rearranging equations, there's always the trusty triangle method. So the nice triangle that we can use for resist R equals V over I, and that involves R here, V here, and I here. We've got our divide sign there, and a multiply sign here. So here, what is the voltage? I always cover up with the triangle rule what I'm looking for. So I'm going to cover up my voltage, and I see that I need to do resistance times current, V equals IR, which is exactly the same as this. So they both work in the same way. So now I know that I'm going to be looking at V equals IR, voltage equals current times resistance, equals my current is 4 amps, times my resistance, which is 5 ohms, which is equal to 20. Now I need to remember the units. The units of voltage is volts. So I need to make sure that the units I use match the quantity that I'm looking for. So that's one other way to do it. There's one more thing that might ask, which is probably the hardest way to do it, which is this. What is the current? Okay, when they're asking for the current, this is slightly more difficult. What is the current through a 2 ohm resistor with a PD of 20 volts across it? So I'm going to go back to my equation, R equals V over I. Now, for the pure maths people who like doing maths, I need to get I on its own. I don't want to have it on the bottom. So I'm going to take I up to the top here. So I want to get I up here so it's on the top. So I then have that IR equals V, which is what we had before. IR equals V. But I want I on its own, so I need to move R. And I need to move R onto the other side. And if I times R equals V, then to get it onto the other side, what I need to do is I need to divide V by R. And it's really important that we get this the right way around. V over R, not R over V, it's different. So if you're okay with rearranging equations, that's a really good method because that's a really powerful way. Whatever equation you have, you can always use this type of method. If you don't like that though, we can go back to our triangle, which looked like this. R equals V over I. And I want to know the current, so I cover up the current, and look, lo and behold, I get exactly the same equation, V divided by R. So I know now that I need to think about the equation I equals V divided by R. I've not written my things up here, so R equals 2 ohms, V equals 20 volts, I equals, we don't know. So if I equals V over R, we need to plug those numbers in. V is 20, R is 2 divided by 2. So I is equal to 20 divided by 2, which is equal to 10, and I need to make sure that I've got those units in there, which is amps. So remembering that each time we do the equation, we need to make sure we use the right unit for what we're looking for. So amps for current, ohms for resistance, volts for voltage. And we need to remember that we can't just use the equation R equals V over I like this for any situation. We have to rearrange it. So if that's using maths to rearrange or the triangle, it's up to you. So the really important things about Ohm's law are that we have this triangle for our equation. We have this equation if you don't like triangles. And if you drew a graph of I and V, like so, you get a nice straight line because the two are proportional. Ohm's law in two ways, a straight line graph or R equals V over I.